Okay, hello and welcome to assignment 3. Now, one of the things for assignment 3 that we want you to do is get good at understanding requirements and being able to sort of read things multiple times and synthesize and understand what's going on. That being said, I'm going to do a pretty short video just giving a high-level conceptual overview of some of the stuff that's going on because it's quite abstract and that's intentional, but yeah, hopefully this helps you out a bit. So we talked about in the lecture on event-driven design, which I would recommend watching if you haven't already, event-driven and asynchronous design, which is in week 8. We talked about producers and consumers and this idea that, I'll just bring up a diagram to illustrate it better. Here's a producer. That's not a good drawing. Producer, consumer, and they operate over this sort of stream-like kind of shared channel, which we're calling a tributary in this case. Here's our little, river, whatever you want to call it. And the producer deposits events in the channel. And then the consumer picks up those events and does whatever, some stuff with them. That's the basic model. Now, what this assignment is saying is let's take that up a notch. Where we have, okay, the first thing is we have different types of topics, and topics relate to events of a conceptual type. So maybe in this tributary, you've got these green events. Here's green, and then you've also got some red events. And so maybe we have another producer over here, which produces red events. And the consumer, I think in this case, one consumer, or I should say a consumer group consumes one type of event. Let's say we have another consumer that's interested in red events. So conceptually, these green and red events are separated into different topics. And an event is parameterized, a topic is parameterized on a certain type of event. So that's the first thing. You kind of separate the tributary into different topics. Let's maybe draw that. So, here's your overall stream. And then we have the red topic and we have the green topic. Now, within a single topic, we can separate into partitions. Partitions are a way of, like in actual Apache Kafka, of splitting up the sending of messages across multiple physical machines. Like if you think of partitioning of a database, for example, it's where you actually take the database apart and put it on multiple different machines. That's where the idea comes from. We're not obviously doing that in our Java program, right? It's all just running on a single program, but kind of conceptually, we're going to be splitting up each topic into a series of different, basically buffers or arrays, right? These are the partitions. So let's take the green topic as an example. So within this single topic, we might have 3 different partitions. Here's partition 1, number 2, and number 3. And I've kind of drawn it as like a queue essentially, and this will form, just like a buffer. And this buffer will, be different in size depending on the number of events that are stored in the buffer. And we can kind of see that here, right, where you have a topic and then multiple partitions within the same topic. So if we want to send a message, let's say this producer is sending a message to the green topic. It says, okay, I want to send a message to this partition. And so that message gets appended onto the end of the queue. That's how producing happens. Consuming is kind of interesting if we go down to consumer groups, because consumer groups consist of consumers which are coupled to partitions. So let's say I've got my my green topic here, and I've got a consumer group which is going to read from the entire topic. So you can think of, say, well, one consumer group reads from a whole topic, and a consumer reads from one or more partitions. So within this consumer group, I'm just going to label some of these, call this my topic, make that a bit bigger. I'm going to do that. 30. There we go. So here's our topic. And here's our partitions. And then this is a consumer group. And then here's a consumer. Maybe we get a shape. Yeah. Let's make this orange. There we go. So consumer reads from, let's say this partition and this partition. And then we have another consumer which reads from this partitions. So you always have the number of partitions. Oops, that's not what we want. Number of partitions is greater than or equal to number of consumers. So you'll never have the case where you have like 4 consumers and 3 partitions, for example. There's some stuff to do with rebalancing, the way messages are allocated to partitions on the producer side. I'm going to leave that for you to read in the spec. That's some kind of high level stuff if you want to go further with this assignment. Probably the only other thing that I'll add is that this consumer group, you could have a whole nother consumer group which is completely different and reads from the same topic. So like at a higher level, like let's say this is now all in green. At a high level, it's like maybe you have a service or a class. Like this is maybe the producer is like a profile class, so the user updates their profile. And then this consumer group here is an authentication service. So when the user updates their profile, then the auth service gets updated. But then there's another service that's also interested in this type of event, which is this one here. And that has a consumer group. Let's say it's I don't know, we've done authentication. It's a provisioning service, right? You're provisioning some sort of resource. So this service gets notified as well. That's the basics of consumers and consumer groups. The only other thing I'll talk about very briefly is replaying, where let's say you have, I'll scroll down to it in the spec, actually, that probably gives the best description. So let's say you have events that are stored in the buffer. And the key thing with these event-driven systems is they don't just enter the queue and then leave it. They actually stay in the buffer because you can go back in time and replay events from a certain point. So in this case, you've got 1 through 9 events stored in this partition. And then you say, okay, I'm going to maybe the consumer is reading from event 6, so it's up to number 6 in the queue. But then we say, okay, and actually go back to number 4 and play all the events from that point onwards. Alternatively, you can say, well, I'm just going to consume events like normal, and we start from 6 and continue forward. And different consumers will have different offsets they're up to. So in this case here, it's like, well, maybe we're up to this place in this partition and this place in this partition. Actually, I'll make these different. And so these offsets will be stored in the consumer. And at any point, if we say, well, let's go and replay, then maybe we'll start from here and it will replay all the events from this point onwards. That's probably all I have to say. If you've got any more questions, please post on the forum. Thank you for listening. Good luck.